Hello student. So the question is to find the number of molecules of CO present in 7 grams of carbon monoxide. So first we'll calculate the molar mass of the CO. So it is equal to, so the carbon atomic mass is 12 gram per mole plus the oxygen atomic mass, which is 16 gram per mole. So the total is 28 gram per mole. So this is the molar mass of carbon monoxide. Now the second is to find the number of moles. Since the number of moles is denoted by N and it is equal to the weight upon the molar mass. So from here we can calculate the number of moles. So the N is equal to the weight, which is 7 gram divided by 28 gram per mole. So by calculating it, it is equal to 0.25 gram. So it is in moles. So it is 0.25 moles. Now since the 1 mole of any molecule is equal to the Avogadro's number, which is 6.022 into 10 raised to the power 23 molecules. So from here, as we know that there are 0.25 moles of CO in 7 grams. So here the number of molecules is equal to the moles, which is 0.25 mole, multiplied by the Avogadro's number, which is 6.022 into 10 raised to the power 23 molecules. So it is equal to, so by calculating it, the number of moles is 1.51 into 10 raised to the power 23 molecules. So this is the number of molecules present in 7 grams of carbon monoxide. Now the next part of the question is to find if the same mass of NO2 is taken, so will it have the fewer molecules or more of the NO2 than CO? So let's see. So let's first calculate the molar mass of the NO2. So here the nitrogen has the atomic mass of 14 gram per mole plus 2 into the atomic mass of oxygen, which is 16 gram per mole. So since multiplying 2, because there are 2 oxygens, so it is equal to 46 gram per mole. So this is the molar mass of NO2. Now similarly, by using this formula, we'll calculate the number of moles of NO2 and it is equal to, so the weight is 7 gram divided by 46 gram per mole. So it is equal to 0.152 mole. So this is the number of moles of NO2. Now we will be calculating the number of molecules. So the number of molecules of the NO2 is equal to the number of moles, which is 0.152 multiplied by the Avogadro's number, which is 6.022 into 10 raised to the power 23. So by calculating it, we'll get the number of molecules of the NO2 and it is equal to 0.915 into 10 raised to the power 23 molecules. So as we can see, the number of molecules of NO2 is slightly lesser the number of molecules than the number of molecules of CO. So here the answer is that it is lesser than the CO molecules. Molecules. So this is the answer. I hope you find this video helpful. Thank you.